Welcome, everybody. This is Baseline Tech Talk episode 23. Oh. And for those of you joining us for the first time, you can find all the previous episodes of Baseline Tech Talk on the Baseline YouTube channel, which again, it is kind of difficult to find, and it's all one word, Baseline Web Training. So when you go to YouTube, search that all one word, Baseline Web Training. You'll find all the previous Tech Talks as well as all of the how-to videos that Dan is producing, which has been somewhere about one a week of extra tips and how-tos, which are really helpful. And for quick intros, I'm Andy Humphrey, RSM for the Northeast. We have Chris Wright, VP of Sales. And we have Dan Conger, our National Training Manager. And today we're going to be talking about soil moisture sensors, which goes right to the foundation of Baseline, how we got started, and along the lines of why we do what we do. And we'll talk about the data and what makes Baseline successful and how we do these things. And as it relates to sensors, Dan's going to take us, but there's the two topics for today, lower threshold and upper threshold. And we want you guys to have a solid understanding of the differences. And we're going to try to make this simple and easy so that you can implement it if it's the first time, or you can take an existing controller to that next level. So Dan, with that, why don't we turn it over to you?
Okay, great. Have you turned on my screen sharing? Forgot to ask you that.
You are on, yes.
Beautiful, beautiful. Okay, well then I'm going to jump right into my sharing. So we're talking about soil moisture sensors and the upper threshold or lower threshold and ways to control those. And I really think that a thermostat is a great analogy to what a soil moisture sensor is trying to do and the way we approach it. I think we'd all agree it would be ridiculous and not a very smart move to manually turn to have a switch for your heater or your air conditioner to turn it off and on, or to do that based off of a time, like every 10 minutes on Monday, Wednesday, and Friday, you're going to turn on the heater. Like, no, that doesn't make much sense. So with a thermostat, we're trying to maintain a range of temperature. We're probably trying to do something very similar with the soil moisture sensor, maintain a range of moisture content within the soil, as opposed to just straight time.
Yep, and there's a couple things that make the thermostat so simple. We have a lot more restrictions in the landscape, so we'll talk about this. But what we're all faced with as irrigators are those restrictions. And so our systems are set up based on run times, start times, and days of the week. And what's different about the home is that your heat and your cooling can come on whenever it needs to, because you don't have those types of restrictions. And so as we go through this, please be keeping in mind what Dan talks about in relationship to run times, start times, and days of the week. And we'll kind of reiterate this throughout the day or throughout the episode.
That's interesting, because there is another layer to it, right? It's rare, or it's not that common that you could just turn on your water anytime the moisture dries down. So there's another layer to that. So a soil moisture sensor is really just another device to gather data. So the other devices we've got flow data that can come in, we've got pressure data, soil moisture, we've got temperature, all these data points that come in. And that's really what a soil moisture sensor is. And this is where it's one of the places where it's different than a thermostat. And the older thermostats actually controlled this one, actually controlled your heating or your AC. Now we're using it as a data point and using it to influence on top of those other parameters that we might have. Now we're getting this data in real time. So it's as it's actually happening, we're getting this and we're able to use it to influence this. The thing about data on an irrigation system is it's all about making better management decisions. The more data you have, the more information you have, the better you can manage your irrigation.
Yep. And if you look at those devices that you have on screen, Dan, the soil moisture sensor came first. So what's really cool about the moisture sensor is a lot of what we have today was all because of that, right? So the old story of, inventing the soil moisture technology and then trying to decide how to get that data from the landscape back to the controller. And the 2-wire technology and protocol that we use today was all sort of developed around that thought of getting the moisture data back to the controller. And so we can kind of thank the soil moisture sensing technology and communication protocol for all the other awesome capabilities that are built in today.
Right on. Right on. Yeah. So we're going to get a little sciencey, a little nerdy here, and we're going to talk about volumetric moisture content and field capacity. So there's a couple of things that go on here. Our sensors are going to measure the moisture content based off of the volume for the moisture within the soil. So one way to think about it is depending upon how much space there is in the soil or the capacity for different soil types to hold moisture, whether it's sand, silt, or clay, that volumetric moisture content is based off of it. So if we think about volume, if I had a bucket, if that silver bucket was filled with soil and water, it's not all soil and it's not all water. So if I were to have a saturated soil, it's not going to read 100% on the sensor. What is it? It's like maybe it's mid to upper 30s, or it depends on the soil type, doesn't it?
Well, if you dropped it in a swimming pool, you would read maybe 39, right?
Yeah.
If there was no sand at all and it was in a lake, that's the maximum you would see as a reading.
Right. So I think that's probably an important thing to remember, is the number is never going to read 100. So, and that's actually a common misperception, right? If I put it in a bucket of water or the swimming pool, it doesn't read 100. It's variable. And it's really about, I like your diagram here with the buckets. So a bucket of sand, a bucket of loam, a bucket of clay soil. There's different capacities for each of those soils. So we know that when we have a sandy soil, we're going to have to water more frequently because it can't hold as much moisture content as a clay soil. And I know that from my time doing installation, is when there's clay soil on a site and it rained, you're a week out before you can work on the site because it's just, there's so much moisture on there. Now, coming to field capacity, a sponge, I think, is a great analogy. It's a great way to think about field capacity. So I had this bucket full of water, and I pulled the sponge out of the bucket of water the other day when I took this picture. And as I pulled it out of the bucket of water, it was obviously the sponge was saturated completely. It couldn't hold any more water. And you can see the water is running out of the bottom of the sponge. And after a couple minutes, the water stopped running out. It stopped draining out. Gravity couldn't pull any more out of it. And that's what we would call field capacity, the amount of water that a particular soil could hold in the face of gravity before it pulls anything out. Now, once I start squeezing it, I can get more water out. There's a lot of water in there. And the squeezing is going to be how much does a sandy soil hold or how much does a clay soil hold. And that's dependent upon the soil type. And the sponge is what it is. So we want to kind of keep that in mind. We want to approach that field capacity. Now, if I pull that sponge out and I try to add more water to it, it's just going to run right out the bottom. And that's wasted water. So we don't want to exceed the field capacity for our soil. So having this information that's our goal, right? Is to not exceed field capacity and to figure out how far below field capacity we can dry out and not hurt our plant material.
Mm-hmm. It's also important to consider, when runoff would occur as you're applying the water too. So one of the key strategies when using soil moisture sensors when we're irrigating that we'll talk about is the cycle and soak process. Because if you just dump a bunch of water on that sponge all at once, it's not going to absorb it all. A lot of it will, run off of it or not get utilized, and soil operates and reacts the same way.
That's right. When I pulled this out of my storage, the sponge was bone dry, and it took a couple of minutes and a little bit of working to get it to fully saturate. I like that. Mm-hmm. Yeah. So as you're getting ready to install a sensor, once you've installed a sensor, before you let it actually control or manage your irrigation, we think it's a really good idea to just use the sensor to collect data. And so here on the left side, I have my sensor assigned to a zone, and I'm using a timed strategy. So I'm still watering based off of my time schedule. So I know I'm telling it how long to water on what days to water. But I'm collecting information. So I've got my sensor is now a window into the soil and telling me how I'm watering based off of time. Mm-hmm. Now I can use that data off of a graph or something like that to decide how far do I want to let it dry down or how much do I want to fill it up, and basically make my decisions going forward based off of the data I've collected over this period of time.
Right. That was very poignant, Dan. A window into your soil.
Ooh, I could make a song about that.
Yeah.
And Dan, I'll point out that you could simply search for your sensor and assign it to sensor spot number 1 and collect the data. Mm-hmm. What's important about what you're showing here is that the assignment process has been made. And the reason that's important is because if we looked at this system 3 months after installation and the sensors hadn't been assigned, we may not even have that information. Right. And so during the initial installation and configuration, it's highly recommended. And if you're a specifier watching, it might be good to put in your spec documents for the contractor to make the sensor assignment so that when we're ready to automate, the sensor has been assigned to the correct zone and it's ready to basically flip the switch to automation. We don't have to go back and look for the design notes and figure out what's the serial number, where is it located, what zone is it in, all of those things. That can be done right at the time of installation.
It's also good with it in timed mode initially to see over a week or a 2-week period as you're irrigating how your sensor reacts to those irrigation cycles. Mm-hmm. And you can determine if it may be buried too deep or the DU of the zone that you buried it in may not be that good and isn't getting as much moisture where the soil sensor is located. Mm-hmm. So you can make adjustments before you flip that switch and automate.
Yeah. It verifies what the runtime is doing to the soil. Is 45 minutes what you thought it was?
Right. Because we come up with those of us that have come into the industry with timed watering, we're used to this, 10 minutes, 30 minutes, 45 minutes, whatever that time is. And it's amazingly consistent across the country. People say, well, this is how long I water a spray zone for. It's like, where'd you come up with that? The sensor is going to tell you how that 10 minutes or 30 minutes is actually influencing it, and it's quite accurate. Mm-hmm. So once you've collected some data, we can talk about some watering strategies, some ways in which you might water. And I'm going to use a gas tank analogy because I think the gas tank on your car or truck is very similar to what the soil profile is in the way we treat them. So one strategy, one way of watering is to do timed. So you're going to have fixed run days. You're going to water every Monday, Wednesday, Friday at 8 p.m. Okay? Well, if we took that to your truck, you're going to fill up the gas tank every Monday morning at 8 a.m., and you're going to run the gas for exactly 10 minutes. Well, some days you're not going to have enough gas to get through the week, and other days you're going to be running gas down the sidewalk. You've had too much fuel in there. That's not necessarily a good call on that one. So that's a time strategy. The other way we could do it is with a lower limit water strategy. That's where we have a fixed run time. The amount of time that it's going to run for each cycle is fixed. It does not change. But the run days, the days in which it's going to apply the water, is variable. So it may give it the opportunity to run Monday, Wednesday, and Friday, but it may not run on Wednesday because the moisture sensor doesn't agree with that schedule and it says, I've got enough moisture content. This is really good for deep and infrequent watering. It's particularly healthy for plants. It's a good agronomically, it's a good way to approach watering with a lower limit. If we brought it to the gas tank analogy, you're waiting until the red light comes on or till it gets to the E. To run it all the way down.
Right. And you know that if you squeeze the handle on the gas pump, 5 minutes is enough to fill your tank, or 10 minutes is enough to fill your tank every time, because the volume, the number of gallons you're putting in will be exactly the same every time, because it's when the light comes on.
Right. Okay. Then the third watering strategy is the upper limit water strategy. So this is where we have the fixed run days. So every Monday, Wednesday, and Friday, absolutely guaranteed it will come on. But the run time, that is going to be variable. So one time it might run for 5 minutes. The next time it might run for 20 minutes. It all depends upon the moisture content in the soil. So we're going to fill up the soil profile with water every time we have it. It's not going to dry down. It's going to fill up. It works really well when you have restricted run days. So restrictions might come from a sports field, right? You can only water 1 day a week or 2 days a week. Or it might come from watering restrictions, from legal restrictions, like there's water rationing and you have 2 days a week in which to water, and you better fill up that soil profile every single time. So, a gas tank analogy again, gas rationing back in the 70s. I just dated myself dramatically. Once a week, you had your day to come up to fill up your gas tank, and if you didn't fill it up, you're hosed. You had no fuel for the rest of the week. So there were definitely people waiting for their opportunity to fill up, and the same thing would apply if it's watering. So those are the three ways in which we can approach them. So we don't need to go into time, but lower and upper limit we want to talk
and just remember, Dan's been talking a lot about it. If you look at that slide, run times and days of the week. So as you think about upper threshold, lower threshold, and using a moisture sensor, it's really about how is that moisture sensor affecting and controlling the run time or the day of the week.
Absolutely. Nice. So let's get into the actual programming, the way we'd actually set this up. So one of the first steps you need to do is you need to assign the correct sensor and set up the linked and primary structure. So the linked and primary means that one sensor is going to influence multiple zones. That's based on the 3200. If it was based on a 1000, a sensor would be running an entire program. There's a slight difference on those. But getting that right sensor, and I don't want to gloss over on that because I think that's really important. Because if here I'm getting sensor 13402, if I thought I was getting that sensor, but in fact I was getting a sensor that's buried in zone 6 instead of zone 1, we're going to get completely different results. It's not going to behave the way we thought. Mm-hmm. So having a named zone and keeping track of, or having a named sensor and keeping track of where your sensors are is just critical to this step.
Yep, and you'd be surprised. Oftentimes, installation contractors don't write down where they put the sensor. They may write down the serial numbers, but they forget or they didn't document what zone it was buried in. And so having that information is critical, and the closer you can enter it into Base Manager as soon after construction, the better. And then we can also help you better remotely when we have all this stuff labeled and in a system.
Yeah. So then we're going to pick a watering strategy. Right now I'm using lower limit, but we'll see both of them. So pick a timed lower limit or upper limit strategy. And then we're going to pick a start below or above percentage, depending if we're doing a lower limit or upper limit. So there's a couple ways to get to this number. It's not mysterious. It's actually, there's a couple of steps to that one. So right now I've got a start below of 24%. So one way to do it is to use the calibration function. So calibration essentially means the controller is going to attempt to find what the field capacity is for the soil. So it's going to have a series of cycles in which to run and use that to help calculate the start below. Now, Chris, you had a pretty good in-depth description of what happens on that calibration. So if it runs for 45 minutes and it doesn't find field capacity, what happens next?
Yeah, it could possibly create some behavior as it's going through to the process of trying to find what that field capacity is that's unexpected and may freak a user out, essentially. So in the calibration process, you've got three options. You've got calibration never, which means that it won't ever go out and try to find its holding capacity. Or you've got calibration once, which means that it'll go through the process once. And then you've got calibration monthly, which means it will go through and do a field capacity calibration on the first day of every month. So calibration isn't used very often, and calibration monthly is rarely used, if at all. But if you do it once, the behavior will be that if the system comes on and runs for the 45 minutes programmed into the zone and it doesn't find field capacity, then the next time the system comes on to operate, say you did your first attempt on Tuesday, then on Thursday, if it's scheduled to run again, it's going to run for 45 minutes plus 20%. So it's going to run another 10 minutes beyond 45 minutes. If it doesn't find it then the next Tuesday, when it's scheduled to run again, it's going to run for 45 minutes plus 40% longer. Okay. And so during that calibration process, if you're doing it that way, you're going to have dry down, obviously, from Thursday to Tuesday.
Right.
So it's going to try to apply more water to try to find that upper limit or that field capacity. And it'll do that process until it finds that limit up to 100% of your runtime. So it could do it up to 90 minutes. And if it doesn't find it after that time, then it'll come back and tell you that calibration failed, and you will have to either increase your run times to try to find that capacity or go through the process again.
Right. So the other way that we see that's even probably more common is to not use a calibration, but to do a observation method. So in that case, an observation method, and that's exactly how I came up with this one, is if you look at the current moisture content, it's 23.5%. I walked out to the zone, looked at it and said, based off of my experience as an irrigator, I want it to dry down just a little bit more, and then I'm ready for it to run. And that's how I came up with 24%. So I looked at it, I'm starting to see a little bit of stress, and anything more is going to be an issue, and I came up with start below. So those are probably the two main methods in which people come up with that start below number. The tracking ratio allows you to adjust each zone up or down. If it's a little, you can fine tune it. And then cycle and soak is going to give it multiple times the water. So that's going to become really important in a coming scenario, the cycle soak. So here's a lower limit programming setup. So here we have a sensor that's assigned to zone 1, and it's a primary, and then the other zones are linked to it. I'm using a lower limit strategy. My start below is 24%, even though right now it's at 23.5%. And then I have start days here. So I have a 10 p.m. start time on Monday through Friday. So I don't want my site watering on Saturday and Sunday because I'm not around. So I've given it 5 start times, 5 start opportunities per week. If you look at it like, Dan, that's way too much water to water every single day. Well, yeah, that would be if it was timed, but it's not timed watering. So the way this is going to behave is at Monday at 10 o'clock, at 10 p.m., if it's below 24%, it will start watering, and it will run for its 45 minutes. Tuesday comes around. If it's again below 24%, if it's dried down below that, it will water again. But come Wednesday, it will, at 10 o'clock, it'll check the sensor. And if the sensor says, no, I'm above 24%, I'm wetter than that, then it won't run Wednesday, Thursday. So it will have every opportunity I give it to water, it will, if it's drier than 24%.
Yep, Dan, so if you guys remember back to the slide that Dan showed about run times and days of the week, what you see historically through the season is in the spring, it could be once a week because it just does not dry out. There's little evaporation, little transpiration. And so you may only get watering once a week. As you move into summer, it may need to water every single day. That could be rare, but it may need to water every single day because that 45 minutes basically could be the daily ET.
Right.
And so you see this awesome historical change in your day interval. So in the spring, it could be once a week. In the summer, it could be once a day. And that day interval change happens automatically with the sensor.
So would you be using water budget while you're using soil moisture sensors?
You could. It just may need to water more. If you had it at 50%, it'll just run more frequently because you're not applying as much water.
Yeah.
Yeah.
So here's a graph showing the run times in blue, and it's always running. This is a different zone, so it's always running 75 minutes every time it waters. But you notice that between May 5th and May 16th, there's 10 days where it did not water. It was scheduled to water, but it didn't need it because it hadn't dried down. Now, come about between the 15th and 16th, it dried down and hit that lower limit line. And on the 16th, it watered up. Now, as we go later in the month, and we'll jump all the way to May 27th, you notice it watered again, but it was 5 days between waterings because it's later in the month. It was a little hotter. Beginning of May, it was cooler and needed less watering.
Yeah.
It didn't take every opportunity it needed to water.
I just counted those day intervals. It went from 10 days in between to 9 days to 5 days. And that would be a sign of the ET rate increasing as summer, onset of summer.
That's good math on the fly, Andy. I'm impressed.
We're impressed. Good. So the other strategy is an upper limit programming. So here we've got a sensor assigned with the primary and link set up. We're using an upper limit, and this time the stop above percentage is 27.5%. The current moisture is 26.2. So next time it has an opportunity, it will water up to 27.5%. Now here's where the cycle and soak is very, very important. My run time is set for 50 minutes, and I gave it a cycle time of 10 minutes. So if it were to run the entire 50 minutes, it would run it in 10 minutes, soak for 30, another 10, soak for 30. So the way this is going to behave is at 7 p.m. on Monday, it's going to water, and it's going to attempt to water 50 minutes, but it will only run 10 minutes. And after 10 minutes during that soak time, it will check the sensor and find out if it's dried, if it's wet, reach field capacity, or if it's wet up above 27.5%. If it hasn't, it's going to run another 10 minutes. And then in that next cycle time, the next soak time, it will check it. Is it still, can I still run my next one? So it might run 3 cycles, so 30 minutes, but the last 2 cycles it wouldn't run if it has reached above 27.5%.
Yep, and the biggest takeaway here is that we don't interrupt a runtime, right? Nice. We cannot just stop watering when we reach. What we do is the controller decides not to apply another cycle. So the cycle and soak with upper threshold is the key to making it work correctly, because if this was just a 50-minute runtime, all it would do is water 50 minutes because there's nothing to, it doesn't stop the cycle like a stop condition. It runs the first cycle, waits, and decides if it needs to apply another one. And it takes that cycle soak, what it learns, and applies those to the link zones. So your link zones get the same number of cycles that the primary zone had.
Absolutely right. Right now, if I didn't have that cycle soak set up in there, it would run all 50 minutes, and that might be too much. It might overflow the cup, if you would.
Yep, and you'll see that on the graph, and I believe the next slide up. If you see a spike way above your field capacity, a lot of users think, why isn't this stopping at field capacity? And there you see some.
Right.
Because it's all about pulsing it and getting the tightest resolution you can with the cycles. And it's almost impossible to hit the field capacity line perfectly, but you can use that cycle capability to try to do that.
Well, and it's about the sensor being able to see that application of water as well. And that will vary depending on the soil type. So in a sandier soil, it's going to see that application of water faster than if it were on a clay soil, where it would take, potentially minutes to even hours for that application of water to infiltrate the soil profile, even a couple of inches. So you need to be cognizant of that and give it the opportunity to apply that first application to break the surface tension of that soil, apply a second to help to force that first application of water into the soil profile deeper, and the third one to really accelerate that capillary action through the soil profile.
So we're getting nerdy today because we're almost out of time. So do we have any questions that we need to come up for? Because we could talk more about this graph, or
and we kind of addressed it already, but Josh Wooten wanted to know, can you calibrate it with the cycle and soak in that program? And yes, absolutely. You want to calibrate it with the cycle and soak, because that will, ultimately determine how long you need to run for that sensor to see field capacity. So if I'm running for 50 minutes trying to calibrate, not cycle and soaking, at 30 minutes, I may start generating runoff. And so that 20 minutes of added runtime is just running off and wasting and not getting into the soil profile. So it's affecting your runtime to reach calibration. So you definitely want to cycle and soak while calibrating.
Yep. And keep in mind, it doesn't double your water window, because the baseline controller being smart and sophisticated, while one zone is waiting, it goes and runs another zone. And so you may have, just a margin of extra runtime, but it's watering other things in the process of soaking.
That's right. If you have your concurrency set up.
Yeah. And
so you're maximizing your design flow. So that's where interfacing with those other 2-wire devices like the flow meters or the pressure transducers or whatever, it's all important, because those other 2-wire devices are helping to manage the operation of the system based on soil moisture sensors.
Yep. And your site may not run clockwise around the building, because one's got to soak and it's got to go find another zone to fill that spot. And so you may have the baseline dance, if you will, with the sprinklers, which can, to new users, make it seem like something's not working quite right, but it's doing exactly what it should be doing, which is maximizing the sensors, maximizing your runtimes, your water windows, your hydraulics, all of that.
I think you just introduced a new topic for another Tech Talk Tuesday, because that
baseline dance
talk. Right? Baseline dance. My zones on are going to be random around the property. What?
Like outside the start time.
That's right. Exactly. All right, we're a little over time. What the hell?
I don't know.
So we appreciate everybody being with us and staying with us for an extra 2 minutes. Sorry we went over. Next week, we're going to take a live break, right, Dan?
Yeah, it's Monday. Monday's a holiday, so Tuesday is going to be the new Monday. So we'll be back on the following. We'll be back on the 15th, and on the 15th, we'll be talking about program priorities and how that impacts how zones run or programs run. Pardon me.
But we don't want you to go that long of a period without any content. So next Monday, we're going to send out a link to the YouTube channel, right?
Yeah, we're gonna toss out, I think, the 10 most recent videos that Dan has created, so you can get an idea for the type of content that we're creating, how to find it, and we'll give you direct links to it. And keep your eyes open for that.
Awesome. All right. Thanks for your attention and participation again this week, everybody. Always a pleasure having you join us. Hopefully you feel it's good content. Go out, be safe, work hard, and enjoy the Labor Day weekend coming up.
Right.
Yep.
All right.
All right. See you guys later. Take care.
Bye.